Hi folks, welcome back to the channel. For those of you that are new here, I'm Johnny Chivers. I have over 10 years experience architecting some of the most innovative, large-scale AWS solutions in the cloud for some of the world's biggest companies. In today's video, we're going to take a look at Amazon Bedrock agents. And what we're going to do is create an agent through code ourselves. Don't worry if you're brand new to cloud, AWS, or even generative AI. I'm going to take you through everything you need. All the code you need is in the link below on GitHub, so please download this now. We will use it throughout. Everything is completely free to complete this tutorial that I've provided, so please give a thumbs up and a like to the video. It really helps me out. You will need an AWS account though. I won't explain how to set up an AWS account in this video, but there are other videos and resources on the internet that tell you how to do this for free. The idea behind this video is to demonstrate the power of generative AI agents using Amazon Bedrock. During this video, we're going to create an agent. It will have access to data that we've stored in an underlying database. In this case, it will be Amazon Athena. Then we'll ask it questions about the underlying data. It will have access to certain parts of that data through queries, but we're going to ask it business information that the queries themselves won't figure out by themselves. Instead, the agent is going to use its ability and generative AI to give us the answer based on the data returned. We do this using a service called Amazon Bedrock. Amazon Bedrock allows us to build scalable generative AI applications while AWS manages the underlying infrastructure. It gives us access to over 100 foundational models at the time of recording. This is growing every day. In this video, we'll use the Claude Sonnet 3.5 model, but feel free to play around with other models as well. We're going to combine this with another part of the service known as Amazon Bedrock Agents. Bedrock agents enable generative AI applications to automate multi-step tasks by seamlessly connecting them with company systems, APIs, and data sources. In today's example, we're going to use Amazon Athena, so this just represents an underlying database. But what I want you to think about as we go through this tutorial is the power that we have. I am going to give it limited information or limited access to the database. It's only able to return customer IDs based on name, and then it will use this information to return sales. I'm going to ask it information like what is the total sales for a customer, or what is the highest, most recent shipping date. If you think about right now without using agents, we have to go in, write the query for each part of the business logic that we want to return. So in the example I just gave, we'd have to go in and write all the SQL that would return for a customer, then aggregate their sales, and then we'd have to write another SQL statement and hide that behind an API to give us the total shipping date. And then if we wanted to do more business logic, you keep going. And instead of building maybe like 10, 20, hundreds of APIs to access this underlying information and apply business logic to give us meaningful results, the agent handles all of this. We'll see how it thinks through its chain of reasoning or chain of thought, depending on what you want to call it. And we'll actually see the steps that it's thinking about to get us the total sales amount or the most recent shipping date. This is all very new, so a word of warning, it's not perfect, but you can really get a sense for where it's going, and it can do a lot of the tasks that you would expect already today. The second word of warning is that I have limited the amount of data that we're returning in each query. So if you were to look at the raw data and then maybe do an aggregation function on it, it may not equal what you see in the Amazon Athena or what you see returned to the agent's console itself. This is completely deliberate on my part for twofold reasons. One, the execution time is lower, and two, the cost is lower as well. This cost me under $1 to run, I think in total by the time of the video, about 2 hours. Most of that cost is through the actual generative AI prompt that you enter and then ask for a result. So the more you run, the more it costs, but keep an eye on it. And I really wanted to keep the costs low so you at home could actually follow this tutorial and start creating things yourself and see the real power of Amazon Bedrock agents. So with that being done, one last warning, download that GitHub from below. It's really important, contains everything you need. And with that being said, let's jump onto the console. Okay, folks, once logged into the AWS console, you want to go to CloudFormation. You can do this just by typing in CloudFormation on the top left-hand side search bar. Once there, we're going to create a new stack because we need to create some new stacks with new resources as standard. Upload a template, choose the template. Now, you need to go to the folder we downloaded from GitHub, the unzipped version, click into the CloudFormation folder, and then go to Create S3 and Athena, hit open, It'll take a little second, hit next. Need to give the stack a name, so I'm just going to call this create S3-Athena, that'll do. And we need a name for that S3 bucket. Now, it's always with AWS, the bucket has to be unique, so I usually put in my name. Then I'm just going to call this agent, and then I'm just going to call this Bedrock. That should do, hit next. I am logged in as my root user, so I have admin permissions to create resources. I advise you to do the same. We can just go the whole way through this to submit. So again, really important to have the permissions to create AWS resources. This will run in the background. It'll take about maybe 30 seconds to 40 seconds. You can hit this refresh icon on the top right, or alternatively, you can hit the refresh by just refreshing the browser. What we're looking for here is everything going green, so you can see the create complete. And then once everything is done, on the left-hand side, you will see it completed over here called create complete. Looking at the next set of instructions, so again, this is the GitHub. Make sure you have it downloaded. I'll have ran through what all this information is already at the start of the tutorial, but for now, we've just done step 1. Next thing we need to do is upload the contents of the bucket folder to S3. There is a certain way we must do this, so please do it exactly the same way as me on the console. So we want to go to outputs, we want to go to the bucket name, and we want to select the bucket name. So I'm just going to copy that because we're going to need it. We want to go to S3, so I'm going to type in S3. We will be using this throughout, so again, just open it in a new tab. It makes life a lot easier. Find my buckets, click it in, and click into the Bedrock bucket. Now, once we're here, we want to click upload. And this is where the magic will happen to make our lives a lot simpler. So I'm just going to minimize that window like so. And inside again the folder that we've unzipped from GitHub, we will have the upload bucket folder. We don't want to upload at the bucket level. We want to upload, or the bucket level folder rather. We want to upload at this level. So click in one. We want to highlight everything, and you want to drag the entire contents across like this. It's important we maintain that structure. We use it throughout, so please, please, please keep the structure. Once we've done that, we can just upload the data. So to do that, we just go back onto the big screen and we say, yep, this all looks good to me. Down the bottom right, upload. This will take maybe 1 or 2 minutes depending on your internet speed. There isn't a large volume of data, and you do not get charged by AWS for importing data itself. So the importation of the data, or the importing rather of the data, is free. So once that's done, you can hit close and you'll see that we have the bucket that looks like this. Ensure your bucket looks like this. We'll need it throughout the tutorial in this structure. Okay, back to the right, you can see that the next thing we need to do is go to Athena and run this DDL. We will be changing your bucket, this little bit here, to the bit that we will have called our bucket here. So we're replacing your bucket with the name of our bucket here. The bit that says your bucket will be replaced by this. So again, let's go to Athena, and to keep things simple, put it open in a new tab because we will need to come back and copy and paste this. Inside the Athena query editor, there will be a workgroup called Bedrock Demo created by the CloudFormation script. You want to acknowledge that everything is fine here. I'm just going to get rid of these tabs. This is from me earlier. Playing around with the demo before I got the CloudFormation script right, so you can see there's a little bit of a in behind scenes bit going on right now. So we'll just get rid of all that. You will have a query editor open, or you can just go new query tab by hitting the plus like so. So let's get rid of that. And then back here, we want to copy the schema. Do not run. I repeat, do not run this. We need our name from here. So we'll do this 3 times to create the schemas, and we should then be able to replace our bucket name. This is creating the schemas that we'll use to read the data from the agent. So this is really important. Once you've read it, you can right-hand click these 3 little dots and hit preview table. This will ensure that you can read the data from the table. Now, if nothing appears, most likely what has happened is back over here when we've ran this query, we haven't updated this correctly with our S3 bucket name. You need to keep the prefix and the suffix on the end. So we need the S3 and we need the customer. So both those things need to be present, and your bucket name needs to be in the middle. And then also your data needs to be laid out, customers, employees, and orders in those folders. So we've got 2 more to run, and we have to do the same again. So back to Athena. On this tab, you can see then we have to create the employees table. To do that, we just get rid of the data, paste that back in, get the bucket name again, go back in, and then delete the word your bucket, and then paste in the actual name of the bucket and run it. Should be successful, and then to check again, just right hand click and preview table. Same thing again, if the data doesn't appear, most likely you haven't updated the bucket name correctly. And then finally, we just want to do the create orders table, and then we want to paste this in, and then we want to run this with your bucket changed again. So just copy that in like this, get rid of all this information called your bucket, and paste it in like so, then run, and we have completed successfully. So this will have created the orders table. It'll appear here. We'll just right hand click and we'll say preview table. And again, if you can't see the orders, then most likely what has happened is that you haven't been successful in changing the bucket name. High level, this is exactly what the Bedrock agent is going to be reading. In the terms of our actual code, it has access to the customers table and the order table. It's going to use the information it knows about those two tables to start answering queries based on our data. It is not bound by the information that it can retrieve. It can do things with that information in memory. So the example we'll see today is that actually we're going to get it to look up a customer, go to the orders table and get all that customer information, and then we'll ask it a detailed question about what is the total sales for that customer. Now, the orders table itself doesn't have any aggregation. We don't have any functions that do the aggregation for the total. It's going to get all the orders and then do the summarization itself in memory, and that's the power of agents. So now we've kind of looked at that briefly, and we'll look at that in more depth again when we actually run the agent, because at that point you can really start to visualize what's going on with agents. The next thing we need to do is run the create API stack YAML. So back over here, and we want to go into CloudFormation, which we have left up. We want to go and create another stack with new resources, and we need to go to upload a template back into that CloudFormation folder from the unzipped GitHub. We will then click API stack, hit open, and then go to next. Need to give the stack a name, so I'm just going to call this API stack, something very boring. API specification. Go into your bucket. We have the API specification, copy URL, highlight, copy URI. URI, not URL, sorry. Copy URI, not URL. Back in to CloudFormation, not Athena, that would help. Paste it in. Okay, results bucket, well that's easy. We have the results bucket right here. We know what we're doing, so you just copy that in and you paste it. Make sure that there's no spaces or anything like that. Leave that as prod and click next. Okay, this time we will get a warning or an acceptance to say that we know we're creating IAM policies and resources. So all the code you need, including the security, is in the stack. I have coded it for you because we're not focusing on building APIs here. We're looking at how we can use Bedrock to access data in Athena, but more importantly, answer questions about that data without having to write all the different queries about it. And that's really the power of when it comes to Bedrock and agents in general, is that rather than writing like 30, 40, 50 SQL statements to do things, we don't have to do that anymore. We can write a few SQL statements or SQL statements or APIs or whatever your language of choice is, and then say, okay, here's how you reach this data. I want you now to figure out the rest yourself. I don't want to write all these aggregation functions, sum functions, things like that. I want you to do that for me as an agent, and I will just let you access the data. You have access to all the rows, you figure the rest out for me. So you can see here we're completely created. That's the create complete. In the background, let's take just a really quick look at what we've done. So that Lambda function has been created that will actually allow it to access the data. So if we go into customer orders API, you can see the code that has been put up for you. The console might look a little bit different because there's a new editor, so that's fine. We'll just switch so we all look the same. Oh, this looks very familiar, whatever this editor is. And you can see then that all the code you need to access the data is wrote here. So what's going to happen is that we will supply it a name, and based on the name, it's going to return a customer ID for us. Then it's able to access all the orders for that customer ID. Caveat, because this is a tutorial, because I wanted to minimize the amount of data and any issues, I have limited it to 20 rows of the order data per customer. So if it has a single customer, it's going to only be able to get us back 20 rows. That is deliberate by me just to keep this easy. So if we take a quick look at the diagram that I've drew on Lucidchart, and it's also on the GitHub, I'll tidy this up before I finalize it. We'll move a few things around just so it's neater. But in general, what we're doing is coming in through the agent, and it's this Lambda function that then lets the agent access the data in Athena, which is stored on S3. So we stored the data in S3, registered it in Athena. There are plenty of tutorials on Amazon Athena, including one on my YouTube channel if you just want to get to grips with that service. I won't cover what it does, but essentially lets us access data on demand. But it's really this Lambda function here that we're looking at is the special sauce with the Bedrock agents and the API schemas. Using that information, Bedrock's going to be able to access the data and then tell us things that actually the query doesn't tell us explicitly. It's going to imply things like it will be able to get total orders, the last order date. It may even be able to get us things like the number of units or the most sold product for that user or customer as it currently stands. Again, this is a very simple example where we're just using customers and one customer at a time. You can actually extrapolate this out to a lot more advanced stuff. I just want to keep it simple for the purposes of this demo and also keep the costs low so you can follow along. Excellent. So now we're actually all set up. We can actually go build an agent, believe it or not. I do find the agent console just a little bit temperamental at times at the moment, but I'm getting more used to it as time goes on. I'm not the most advanced user of Bedrock compared to the other AWS services because I've been using the AWS 10 years. Bedrock's recently new. So again, I just navigated to Bedrock there. You want to click agents and you want to click create agent. It'll ask you a few questions. So we're just going to call this one the Athena Bedrock agent. That'll be easy. Description: this is the Athena Bedrock agent. Okay, that'll do. We don't need anything else and we just want to create. So there's a lot of buttons to click on this console once it's created. So what we need to do is give it an instruction. That's the first thing before we do anything. We have to give it an instruction. So this instruction, we will say, you are an agent for a company that has sales data stored on S3 with customer data. You will be able to retrieve data by customer name and then answer questions about the sale of products to that customer, such as total sales amount. That should do it, something like that. Again, the better the prompt, the better the answers, but this is quite a simple example, so we'll just keep it simple. Now, this is where it gets quite hard. You must save. You have to save before we do anything else. You must save. And you can see that it's preparing the agent there, but we had to save so we can actually do other things. Also, just make sure that you want to actually maybe create a new role there, actually. So just create a new role. I'm trying to use an existing role, but let's just create a new role because it'll keep things simple. So that's me now. Everything looks good. Okay, back down into action groups. You want to add action group. I just leave this as default. It's very pernickety on what you want to call it. We're going to go define with open API schemas or define with API schemas rather. Select an existing Lambda function. It's the customer orders API that we've created. Select an existing API schema. So if we browse and we go into the bucket that we created, that's the wrong bucket. That'll never do. It's this one. No, it's the wrong bucket. Sorry, this is all my fault. Click on this one. Yep. And then it's the API schema. So you want the bucket that we created and then the API schema. You want to hit create when it does its thing. Just so we know, looking back onto the API schema itself, we're going to give it access to the data. So it's going to be able to go in and get the information about customer, which it knows, and the information about orders. Realistically, and we've already kind of semi-looked at that, it is going to, based on the name that we enter, look up for the customer ID, which is here, then put in the customer ID as a where clause, and then search the information for the customer. But again, it won't know any more than this, but we can start to ask it questions. Again, this is quite a derived or contrived example, just to make sure it works. Next thing we need to do is hit save again, Bedrock console, then hit this, and you must prepare the agent. We must hit prepare for the agent. You can see on the right hand side, the agent is preparing. Now we can ask it a question. So the easiest thing to do is to go onto the GitHub, and we have some information about the names. So I'm going to ask it a question about Catherine Abel. So I'm going to ask it is, what is the total sales for Catherine Abel. I'm going to need to put that space in and a wee question mark, and then hit run. And we can see then that this is off and running and thinking about what Catherine Abel has bought. Now, just remember I have restricted the number of rows that will return out of the data. That's just to keep things down. So you can see here, it's returned 20 rows, and that's the total sales for Catherine Abel. This amount includes subtotal, tax, and the freight charges in her order. So it actually has added everything together. Now for agents, this is where it gets even more clever. You can hit show trace. If we look at the step 1 and we scroll down, you can see that we have told the agent that it is a company that has sales data stored in S3. We've told everything about it, what it cannot do. You will always follow these guidelines. And if we scroll down, it's got information about its response. To answer this question, and I think this is brilliant, this is where the power of agents really starts to come in. To answer this question, I will need to retrieve the order history for Catherine Abel and then calculate the total sales. I can use the provided function to get this order by name. Let's start calling this function. So it has actually went in and able to do the trace here, as you can see, and return all the order information. But what happens in trace 2? Well, trace 2, it says, okay, that all worked. Here's all this information that I have got about what's going on. Now that I've retrieved the order information for Catherine Abel, I can calculate the total sales. The total sales can be found in the total due field of the order, which includes subtotal, tax, and freight. Since there's only one order in the results, I'll use that value for total sales. So it's able to figure out that information for you. So clever. So clever. So let's then ask it another question. What is, and again, this is a contrived example, so we are limiting the amount from the database, so it's not exactly right if you went through an Excel or you looked at all the data, but it's to get the examples across. So what is the most recent sales date for Catherine Abel? Let's just take her name again. For Catherine Abel. And let's put that in, run it, and see what it comes back with. So it's off and running. It's often thinking about it. The most recent sales date for Catherine Abel is the 31st of July, 2013. And again, if we hit show trace, we can start to work through what it actually did. So again, usual stuff. That's it knows what it is, what it's doing. And then down the bottom, it should be able to tell us. To answer this question, I need to examine the order history and then look that we retrieved in the previous query. I'll look at the order date. If the field for the most recent date, thinking after review of the data, that there's only one order for Catherine Abel and all her order details have the same date. Therefore, the most recent sales date is the order date. So the agent didn't even run the query to go back to the database. It knew from our previous query that there was only one order. Therefore, why would you query again? And then if I have the order information still in memory, let's just go get the date. I knew this information. I don't need to run this again. So then you can see the final response that it gives me through the trace date itself. Again, you can play around with this and do it for other people. So let's go again and see what happens. What is the most recent order date for, I'm going to put in Kim Abercrombie, but need a wee space in there. It's not clever enough. It might be clever enough actually to work that out as a spelling mistake, but let's figure it out. Kim Abercrombie. It's off and running at the races. Now, there is a little bit of latency. I think that's fine at the moment, so it had to go run that. And if we go show the stack trace, it'll probably tell us what it did. So same thing again, it knows it's an agent, it's going to do stuff. It's got information back about Kim Abercrombie. And we go down the bottom again. Let's see what it did on stack 2. What did it do? I hate this bit. Maybe it's in stack trace step 2. You're an agent for a company, stores data on S3. And if we go right down the bottom and we go back, there you go. Now I have retrieved the order information for Kim Abercrombie. I can determine the most recent order date. Looking at the data, I can see that all order details have the same date, which means Kim Abercrombie only has one order in the system. And that's what it's implied. That's what it's implied. So again, really interesting power of what you can do with agents here, and then the whole Bedrock scenario around it. I encourage you to play around with the data. Again, it's not perfect because of the queries being limited in the size I'm allowing them to return, but what this will be is cost effective, so feel free to play around. This cost me less than $1 to set up and run for about 60 minutes, just hammering queries at it. Pay attention to the Bedrock query and the amount, but because we're using Claude 3 on this example, it's very cost effective. If you want something slightly more cost effective, go to Nova Lite, which is now available, the Nova Lite Amazon model, but stay within these parameters, and I encourage you to play around with agents. Last thing to do, and I won't do it here, is start to delete those resources. So you'll need to delete the Bedrock agent manually, then delete the contents of the S3 bucket, and then finally go back to CloudFormation and start deleting the stacks by clicking delete stack. So again, if you're new to CloudFormation, you would just go back to CloudFormation like this, click on the stack, which will take a little second to load, stacks. Once it loads, click on the stack and then delete stack. Join me off the console and we'll do a little recap of the power of what we have just seen. Well guys, thanks for following along with this tutorial. I hope you got a great insight into how Amazon Bedrock can be used for foundational models, how you can use Amazon Bedrock agents to start actually abstracting business logic away and not write endless API queries to get at your data. Again, this is early days in the generative AI trend. It's really important that you learn this stuff to get ahead of the curve and we can see what's coming around those corners. One last call to action, like and subscribe please to the channel, it really helps me out. And until next time guys, thanks for watching.